Welcome to the YouTube channel PCMB Tutorials. I hope you all are fine. Today we are going to learn Class 9th Physics Chapter Heat Part 6. In this part we are going to learn types of expansion of solids. As in previous part we have started with the topic expansion of solids. So first type is linear expansion. Second is superficial or surface expansion. Third is cubical or volume expansion. Now let us start with the first one, which is linear expansion. So I am drawing something on the board. This one is the thin rod which expands on heating. The increase in its area of cross section is negligible when compared to its length. The rod, the expand in the rod, the expansion is noticeable along its length. This is called linear expansion. Factors affecting increase in length. Factors affecting increase in length. First is rods of different lengths but made of the same material. Second is rod of same length but heated through different rise of temperatures. And third one is rods of the same length but made of different materials. Let us see them. First one is rods of different lengths but made of same material. Heat two aluminium rods of different lengths through the same rise of temperature. We observe that greater the length of the rod, greater is the increase in length. Thus, we can conclude that an increase in length is directly proportional to original length of the rod. That is, increase in length is directly proportional to initial length. Second is rods of the same length but heated through different rise of temperatures. Heat two aluminium rods of the same length through different rise of temperatures. Say first rod up to 40 degrees Celsius and second rod up to 80 degrees Celsius. We observe that the increase in length is greater for the rod heated through greater rise of temperature. Thus, it can be concluded that an increase in length is directly proportional to the rise in temperature. That is, increase in length is directly proportional to rise in temperature. Increase in length is directly proportional to rise in temperature. Third one is rods of the same length but made of different materials. Now, heat the iron and aluminium rods of the same length through the same rise of temperature. We can observe that expansions are different for different materials. Thus, we can conclude that increase in length depends upon the nature of the material. increase in length depends upon nature of material. Thus, increase in length of a solid is directly proportional to initial length of the solid, rise in temperature of the solid, and nature of the solid. Now let us see the mathematical expression for linear expansion. So let us start. If L1 and L2 are the initial and final length of the rod at T1 degree Celsius and T2 degree Celsius, where T2 is greater than T1 respectively. So before heating and after heating, we'll take before heating, after heating. Initial length of the rod is L1. Initial temperature is T1 degree Celsius. T1 degree Celsius. Rise in temperature is equal to final temperature minus initial temperature. After heating, there will be final length L2 and final temperature T2 degree Celsius. Rise in temperature. Rise in temperature is equal to final temperature minus initial temperature. Increase in length is equal to final length minus initial length. Increase in length is equal to final length minus initial length. The increase in length is L2 minus L1 directly proportional to L1, equation 1, and L2 minus L1 is directly proportional to T2 minus T1. Combining equation 1 and 2, we have L2 minus L1 is directly proportional to L1 T2 minus T1, or L2 minus L1 is equal to L1 alpha alpha, or else I will write like this: alpha T2 minus T1. This is equation 3. Over here, this alpha is called the coefficient of linear expansion. This A, alpha, is called the coefficient of linear expansion. Change in length is equal to original length into coefficient of linear expansion into change in temperature. Or we can write L2 equal to L1 in bracket 1 plus alpha change in temperature and change in temperature is equal to T2 minus T1. T2 minus T1, where T1 and T2 are the initial and final temperatures respectively. Now let us stop till this. In part 7 we'll see continuation of coefficient of linear alpha expansion, signification of coefficient of linear expansion, units of coefficient of linear expansion, and then superficial expansion, or we can say areal expansion. We'll learn this in part 7. I hope you have understood till this. Thank you for watching. Let us meet in part 7.